Hello there and welcome to a brand new lesson. This is How Beyond Numbers where we learn maths the easy way. In this lesson, you'll be solving a question, and by the end of the question, you should be able to estimate the difficulty level of test items. You should be able to distinguish between easy, moderate, and difficult test items. You should be able to estimate discrimination indices using the upper and lower group method. To interpret discrimination indices, to evaluate item quality, and finally, you're able to use item analysis to improve test construction. In the course of the lesson, you'll be hearing of these terms. So let me quickly take some few minutes to explain the terms as they'll be needed for you to solve the question. The first thing you need to know is item difficulty. The item difficulty level, whose symbol is P, is simply the proportion of students who answered an item correctly. You see, so when we talk of proportion, it is simply the number of students over, that is the number of students who got it correctly over the total number of students. You see, now if you solve this and then you get a decimal, it is always between 0 and then 1. If it is greater than 0.7, then we say it is actually an easy test. If it is moderate, then it should be between 0.40 and then 0.70. But then a test whose term difficulty level is less than 0.41, that should tell you that it is very, very difficult. We'll be solving a question on that. The next term you should look out for is the discrimination index. So this is also known as the item discrimination level. What it does is it measures how well an item distinguishes between high performing and then low performing students. Now, there are so many ways you can actually solve it, but its formula is the upper group that got it correct minus the lower group that got it correct all over the number of individuals in each group. And most importantly, you should know that the number of individuals in both the upper and then the lower groups are the same. There is the 50-50 method, and then there's the upper and lower group method, which we will be using in this lesson. So for the upper and lower group method, what do you do? You split students into upper group and then lower group based on their total scores. Then you compare their performance on each item. As we solve the question, I think this will be clearer. Now, if you have the discrimination level being greater than 0.40, it is excellent. It means you were able to actually what distinguish. If you have 0 point between 0.30 and then 0.39, it is good. 0.20 to 0.29, it is fair, and then you need some revision. But then if you have anything that is less than 0.20, then it is very, very poor, meaning you are not able to actually distinguish between the high performing students and then the lower performing students. You can even get 0. And actually, it is every teacher's aim to actually get a discrimination level of 0, which simply means you've been able to really teach for the students to understand, and hence both the low performers and then the high performers are getting the concept. But then that is actually once in a million. One thing you should notice: when your discrimination level is negative, that is also a problem, which we would consider. With all this said, let's quickly look at the question and then we solve. So looking at our question here, it says, in a class of 10 students, the score of 6 selected objective test items and their total scores are provided in the table below. Use the information in the table to answer question A and then B. So as you can see, we have our table here, which is response of students in 6 objective test items. So these we see here are the student IDs. Don't let them confuse you. So student ID 15, 16, 17, 18, 19, all the way to 24 from a larger register. Then we have these items. So that is to say, the student with ID 15 had item 6 correct. That of 16 had 6 correct. Then that's other. Okay. So this is the table. You can pause and quickly study it. Now let's look at the questions that come after these. It says, first of all, we are to estimate the difficulty level of item 6. Then we have to study, then we have to also estimate the difficulty levels of item 8 and then 10 as well. So let's do that first part of the question. So talking of the difficulty level, let's once again visit its definition. So as you can see right here, we said the item difficulty. It is the proportion of students who passed an item correctly. You see, and then it is giving us what? The number correct over the total students. You see that? So for what we have over here, for item 6, first of all, we already know the total number of students. So we can say total number of students. Let's just say T is equal to what? 10. So if there are 10, let's go to item 6 and then let's look at the number of students who had it correct. So this here is item 6. And as you can see, there are 10 individual students, with these being their index. Those who had it correct, we have 1, 2, 3, 4, 5, 6, and then 7. Just 7 students had it correct. All over what? The 10. Hence, estimating the difficulty level of item 6, it is simply going to be P is equal to what? 7 all over 10. You see, and you can evaluate that to get your 0.7. Same applies to item 8. So let's go all the way to item 8. And then we check how many students got it correct. So as you can see, all got it correct except 1. You see, so that is a 9. Hence, for item 8, the level of difficulty, P, is simply going to be what? 9 over 10, which also gives us a 0.9. Then we come to item 10. So as you can see, item 10 over here, it has 1, 2, 3, 4, 5, 6, 7, 8. So our P is going to be what? 8 all over 10 as well, which would also give us a 0.8. Now, if you remember, we spoke about the classification. We said if whatever you have is greater than a 0.7, then it simply means it is not difficult at all. It is easy. If it is between 0.40 to 0.70, then it is moderate. And then a less than 0.4 simply means what you have or the test is actually difficult. So if we come here, all these are 0.7 and above. So it means item 6, item 8, and item 10 are very, very easy. That is how come all the students or most of the students are getting it correct. So that is it for estimating the difficulty level. Now let's go to using the upper and lower group method to estimate the discrimination indices for item 7, 9, and then 11. Now, when it comes to estimating the discrimination index, there are three key steps we need to know. First of all, you have to arrange all the answer sheets of the student in descending order. What I mean is their total scores. You'd have to arrange it in descending order from the highest to the lowest. So, as we can see from the table we have here, they have all been what? Arranged in descending order. Hence, our first part is done. Now, after arranging in descending order, the usual procedure is simply to calculate some number, which is usually between a quarter and then a third. All right. But most of the times, when the sample points are about 25 or 45, we simply go for top 10 and then last 10. You see, but since this our sample size is just 10, we are going to go for a third, or in other words, just a 27% of the number of students we have over here. Now, since they are 10, if you want 27% of 10, that gives you a 2.7. And 2.7, if we want to approximate it, then we are talking of 3. You see, hence, if we take this table, this is what we are going to do. We are going to take note of these top 3 students. You see, we are taking note of these top 3 students, and then also take note of what? These bottom 3 students. And it is their data that we are going to use to what? Solve for the next question. You see, so the top 3 and then the last 3. Why top 3? As I said, you are looking for 1/3 or 1/4, either of them, or in other words, 27% of the total number of students. In this case, we have 10 students. And take note, if the number of students is between 25 and then 45, we actually use the top 10 and then the bottom 10. But since in this case we have just 10, we are not going to use top 10, because if you are to use top 10, then the top 10 is simply going to be the whole data point. Below or bottom 10 is also going to be the whole data point, and that wouldn't make sense. You see, hence we take just a third, 1/3 of it, you see, and 1/3 of it is what we have taken over here. So now that we have this data, we now look at the formula that we use to solve for the discrimination index. So as you can see over here, it says the discrimination is equal to what? The upper group correct minus the lower group correct all over the number of each group. So the number of each group we are talking about here is simply 1, 2, and then 3. There are only 3 numbers or students in this group. And over here too, there are only 1, 2, 3 students in this group. Hence, the number in each group in this case or in either case is going to be 3. So our n is equal to 3. Then, looking at our question, we are working on item 7, item 9, and then item 11. So with that, for item 7, we are going to denote those in the higher group as H. And then those in the lower group will denote them as what? L. And the total number of individuals in each is going to be a capital N. You see? So for item 7, looking at those in the higher group, you realize that all 3 got it correct. You see, so for item 7, we have H being equal to 3. But for the lower, we have just 2 students. You see, so we are going to let H here be 3 and then L here be what? 2. Let's quickly just write for all, after which we can then solve. So for item 9, the H is also 3 and then the L is 0. So for item 9, we have H being 3, then L being 0. Then for item 11, H is also 3. And then for L, we have just 1. You see? So now that we have this, we know that our discrimination index, that is D, is giving us what? H minus L all over N. And take note, the N is the number of individuals you have in each group. So N is simply 3. So the index for item 7 is simply going to be H, which is 3 minus L, which is what? 2. All over how many students do you have in that group? We have 3 students. You see, and if you have to evaluate this, you are going to get a 1 over 3, which is approximately a 0.33, and then it's just continuous. So 0.333. Let's look at that of item 9. So the discrimination index for item 9, we are going to have what? Still using this formula, H minus L, and we have its H and then its L. So we have 3, then minus 0 all over what? 3. And that gives you a 3 over 3, which is a 1. You see? Then we come to the last one, which is for 11. So we have D of 11 being equal to what? H, 3 minus 1 all over 3. And that also gives us a 2 over 3, which is approximately a 0.66, let's say 7, since it also recurs. So we can then come here and say that since we already know what these are, let me just clean them from there. And then the discrimination index for item 7 is simply a 0.33. That of 9 is 1. And then that of 11 is a 0.67. What do these mean? Let's go back to the clarification and then get what they mean. So as we said here, we said we know the index is always between a 0 and then a 1, right? So if it is greater than a 0.4, then it is an excellent discriminator. If it is between 0.3 and then 0.39, then it is good. From 0.2 to 0.29, it is fair. Anything less than 0.2, it is a poor indicator, you see. So in this case, for our item 7, it is a good indicator, you see. And then for 1, which is for greater than 4, then it is an excellent indicator. And then item 11 is also an excellent indicator. So this is how we solve for what the difficulty level and the discrimination indices or index. See you in our next lesson. And if there's any issue of concern, you can always let me know at the comment section. All the best in your exams and bye.